Did you know that all around us right now, tiny, invisible battles are happening? In our bodies, in the ground, even on our skin. Today, we're going to pull back the curtain on the hidden chemistry that keeps our world in balance, the amazing reaction between acids and bases.
I know, it sounds like the start of a really weird joke, right? You've got a burning stomach ache, a surprise sting from a bee, and a farmer just trying to grow some crops. What on earth could possibly connect these three completely different things?
Well, for that awful burning feeling of heartburn, you'd probably reach for an antacid, right? Something like milk of magnesia. It works by calming the excess acid that's churning around in your stomach.
And if you get stung by a bee, its venom is pretty acidic. The secret to getting some relief is often a simple base, a weakly alkaline substance that fights back against that acid.
It's the same story with farming. When soil gets too acidic, maybe from acid rain, crops really struggle. So farmers have to treat the land with substances like slaked lime to make sure their plants can actually get the nutrients they need to grow. The solution to every one of these problems is exactly the same. It is not a coincidence, it's chemistry. It's a single powerful process that restores balance where there was chaos.
And that powerful process is our first stop, a chemical balancing act we call neutralization.
Okay, so here's the core idea for this whole explainer. Neutralization is what happens when an acid and a base, two total chemical opposites, meet. They don't just mix, they react, and they transform into two completely new and usually much calmer substances, a salt and good old water.
This simple equation right here is the blueprint for everything we're talking about. From your stomach to the soil, this is the fundamental reaction that brings things back to neutral. It literally cancels out the aggressive properties of both the acid and the base.
And this balancing act isn't some quiet little affair. It's an exothermic reaction, which just means it releases energy, usually in the form of heat. That warmth is a real, tangible sign that a powerful chemical change is happening.
So to really understand this reaction, we need to get to know the key players. So in Section 2, we're going to see how acids meet their match. So what really makes an acid and a base a base? It all comes down to ions. Acids are all about their hydrogen ions, H+. Bases, on the other hand, are defined by their hydroxide ions, OH-. They are perfect chemical opposites.
And here is where the real magic of neutralization happens. On the ionic level, that reactive hydrogen ion from the acid combines with the hydroxide ion from the base. They cancel each other out, forming a stable, neutral molecule of H2O, water. The conflict is totally resolved.
But hang on, what about the other product? Water gets all the attention, but there's a real unsung hero in this reaction. So welcome to Section 3, where we finally meet the salts.
Now, when I say salt, you're probably thinking of the stuff you put on your fries. But in chemistry, salt is a much broader term. It's the compound left over after the hydrogen from the acid gets replaced by a positive ion from the base. Table salt is just one of thousands of different kinds of salts, and they're essential for everything from fertilizers and batteries to medicines and keeping our food fresh. So, if we can make all these different salts, how do we actually do it? Well, let's dive into Section 4, how to make a salt. You can think of this as a kind of chemist's cookbook.
Now, before you start any recipe, you need to know what you're working with. In salt making, the very first question is always, will my final product dissolve in water? This is called solubility, and it's the key that determines which of our two main recipes we're going to use.
For salts that dissolve in water, our recipe is crystallization. First, you react your acid with a solid, something like a metal carbonate. After you filter out any of the unreacted solid, you gently heat the salt solution to concentrate it. And then, the magic happens. As it cools, these beautiful, pure salt crystals just appear right out of the liquid.
But what if your salt doesn't dissolve? Well, the recipe for that is even easier. It's called precipitation. You simply mix two solutions of different soluble salts together and poof, your new insoluble salt instantly appears as a solid. All you have to do then is filter it out, give it a wash, and let it dry. It's an incredibly direct way to make exactly what you want.
All right, now for the really fun part. Not all salts behave the same way. In our final section, let's explore some of their unique salt personalities.
First up, we've got the deliquescent salts. These things are so thirsty for water that they will literally pull moisture right out of the air around them until they've collected enough to completely dissolve themselves into a puddle.
A close cousin is the hygroscopic substance.
Now, just like a deliquescent salt, it loves to absorb moisture from the air. But here's the key difference. It doesn't dissolve. It just holds on to the water, which makes these substances excellent drying agents.
And then you have the complete opposite personality, the efflorescent salts. These are salts that already have water locked into their crystal structure, but if you leave them out in the open air, they'll actually release that water, often crumbling from a nice defined crystal into a fine powder.
And that water has a special name, water of crystallization. It's not just, wetness. It's a fundamental part of the crystal structure. A perfect example is hydrated copper-2 sulfate. It's a beautiful blue crystal, but if you heat it, you drive off that water, and it turns into a plain white powder. That hidden water is what gives it both its shape and its color. How cool is that?
So there you have it. From relieving heartburn to growing our food, the simple reaction of an acid and a base is a fundamental force for creating balance in our world. And that leaves you with a final thought. Now that you know what to look for, where else is this hidden chemistry at work all around you?